Empson and Levi tackle the challenge of teaching children fractions in their text, Extending Children's Mathematics, Fractions and Decimals. As postulated in previous articles read this semester, such as Pesach and Kirshner's, this book stresses the importance of relational instruction when introducing the concept of fractions. Relational thinking problems appeal to children's natural intuition when it comes to dividing. As the introduction shows, students have some understanding of the concept of fractions even before instruction. However, often students ignore their own intuition when it is interrupted by the narrow models of fractions presented in schools. To heighten the students' learning experience, Levi and Empson suggest instruction through equal sharing problems and multiple group problems. In Chapter 1, we explore equal sharing problems and guidelines for introducing them. Equal sharing problems present the children with a challenge they can probably relate to real life, dividing food equally among several people. Problems such as this: Jeremy is making cupcakes. He wants to put half a cup of frosting on each cupcake. If he makes 4 cupcakes for his birthday party, how much frosting will he use to frost all of the cupcakes? Play on children's understanding of sharing and partitioning to guide them toward the concept of fractions. The authors advise that you pose the problem without providing instruction. Students should be encouraged to use their own strategies and understanding of the situation to arrive at an answer. For students who do not find a solution, it is helpful to hear other students explain how they solved the problem. Equal sharing problems can be introduced as early as kindergarten, beginning with dividing groups into whole numbers. Halves can be introduced at this stage, or problems with 1 or 2 remainders divided amongst 2 or 4 sharers. By 2nd grade, fraction names should be introduced, i.e. 1/4, 2/3. Once children grasp the names, symbols may be introduced. In 3rd grade, answers may be less than 1 and the number of sharers increased to 10 for most students. Discussions about equivalent amounts, i.e. 2/3 equals 1/2, begin. In 4th grade, the teacher should begin representing children's answers with equations. By 5th and 6th grade, the number of sharers may increase to 15, 20, and 100. The teacher begins representing the word problem situation using equations. In Chapter 2, Empson and Levi present many case studies of 2 very different classrooms to highlight the universality of equal sharing problems when teaching fractions. Miss Murphy's class consists of both kindergarten and 1st grade students. About 70% of the children in her school come from low-income families. She has her children solve problems such as Julian and his sister have 6 cookies. How many cookies would Julian get if he and his sister shared the cookies equally? When she sees the students have grasped this concept, she introduces the fraction problem. Sherelle and Tyrone got 7 brownies at an after-school club. Miss Carolyn told them that they could share the brownies as long as they each got the same amount. How many brownies would each person get? With some encouragement, children eventually come to the solution of having 1 brownie without the need for explicit instruction. By the end of the year, the majority of the class can provide an answer for situations where an odd number of items is shared between 2 people. In contrast to the demographics of Miss Murphy's room, Miss Neha teaches 7th graders at a high-income school. She feels her students are lacking in their understanding of fractions, so she introduced equal sharing problems, such as 16 kids need to share 12 pounds of clay. If they share the clay equally, how much clay would each kid get? To refine her students' concepts of fractions and prepare them for high school algebra. Her students respond positively and indicate that they enjoy their mathematics instruction more. In Chapter 3 of Extending Children's Mathematics, Empson and Levi introduce multiple group problems. Multiple group problems can be used when the students already have an understanding of fraction and as an introduction to computations with fractions. These problems involve a whole number of groups with a fractional amount in each group. Again, problems such as each small cake takes 3/4 of a cup of frosting. If Betty wants to make 24 small cakes, how much frosting will she need? Draw on real-world situations and concepts that students can easily process. Problems are posed without explicit instruction, and students use their own understanding of the situation to arrive at a solution. These problems complement equal sharing problems well and have been shown to refine students' understanding and enjoyment of learning fractions. Extending children's mathematics. Emphasis on relational learning aligns with most current research on elementary math instruction. Allowing students to explore math problems and correlate them to real-world experiences creates a culture of curiosity and usually enjoyment in the classroom. I would certainly use these strategies when approaching fractions in a classroom.